and I can set up super easy even with PowerShell. So I will do a new setup with PowerShell with one commandlet. New SR partnership. Is there like a train going by? What is this place? I'm in an aircraft hangar, there's a train, swarms of flies are attacking me. Atlanta's like, it's like being in the Congo right now, it's crazy. All right, so all of this stuff, you can see I'm just picking a drive. I also have the little short aliases here, so if you want to make all this fit into one tweet, it definitely will fit in one tweet. I hit OK, or I press enter because it's PowerShell, and we look over here and we can look with all my brand new beautiful performance counters how it's doing. So I'm going to show my little N drive here, and I don't like perfmon, so we made our own little performance counter viewer thingy so you can actually see what it's doing. And you can see here that I'm pushing, I've already done like, what is that, 3 gigabytes worth of data. It's just cranking. Here's the rate it's going at right there, cranking up. You can see multi-channel is happening right now because it's using SMB3, so I'm like eating all that pipe. There's no, like with DFSR, you're like, please will you go faster? And with storage replica, you're like, please will you go slower? It's a totally different problem you have now. You can see here, cranking along, and I'm probably going to, at this point, time compress so we don't sit here and wait all day. Actually, it's almost done. Look at the CPU. See the 9 number there? I'm using about 10% the whole time. 10% CPU. Now, how long did this take? 861 seconds. How long is 861 seconds? I don't know. We got calculator back. Yeah! Real calculator's back on Windows Server. I just needed an excuse to show it. 14 1/3, so 14 minutes. I did 1.45 terabytes at a 50-kilometer round trip. I was going 50 kilometers in that demo. 1.75 gigabytes per second. That's pretty fast. Okay, why do I keep showing iWARP? I love iWARP. I love Chelsio's stuff. They have awesome performance. They let you use your existing TCP/IP infrastructure. Where's Didier? Where you at, Didier? Sorry, buddy. Didier is Mr. Rocky. You got your Rocky problems? Right there, buddy. Go talk to him. Oh, I forgot to configure DCB and PFC and this, that, and the other. And, that's how he's building so many hours, because he supports Rocky. No, I'm kidding. Simple setup, price, stable, scalable. I mean, you can believe all my slides here, or you just go back and watch that demo again. I set up Chelsio by plugging 2 cables in, plugging them into a switch, having that switch have some fiber. That was it. That was my whole setup. It took 20 minutes. Of the network, it took 20 minutes. And it's TCP, so it's naturally long haul. You can definitely long haul with InfiniBand, and there's some various options for routing with Rocky and stuff. But with TCP, it's just the simplest one.
So our record to date, which I showed off Monday, was over 6 million IOPS in read. So that's pretty good, we think. Can we do interesting scenarios there as well? So now we're effectively going to swing all the 704 VMs using VM Fleet from doing read-write I/O to just do read I/O, right? That takes a minute because we're going to actually reconfigure all of the 700 VMs, and then as the VMs pick up the change, you'll see that the I/O starts increasing. 2.8, 2.9. How far high do we think we can go? 3.6? 5? 6? 6.6 is actually as high as this particular system goes with an all-read workload. The other point is, you still see the CPU, that is the hypervisor, which includes all the storage I/O as well as the networking traffic across all these machines, still sits at 10% of the CPU consumption, which is very efficient. This is actually due to the fact that Storage Spaces Direct is embedded in the kernel, and we leverage RDMA-enabled networking, which is also during kernel time. So we are super efficient here. The other point I want to make is that you can go to my session on Wednesday at 4 p.m., where we go in great detail with Storage Spaces Direct, and I will show you throughput numbers. This was IOPS numbers. I'll show you throughput numbers that will knock your socks off. Thank you.
Discussion on costs, though, I want to point out that in Server 2016 and in Windows 10, with the releases that have been coming out in the last week, Windows 10 now supports RDMA as well. And so I've asked Bob Dugan from Chelsio to come up and give us a quick demonstration of a Win 10 client using RDMA to access data that's on a Win 10 file server. I mean, sorry, a Windows 2016 file server. The question comes up all the time, why, what would you recommend, RoCE or iWARP? And the answer is, it depends. There are advantages to both. If you look inside of a data center like Azure, and you've got full-time networking engineers who know what they're doing, RoCE is a great solution. However, our number one customer complaint with RDMA is it's too hard to configure. So we have this little slide that talks a little bit about why you might want to consider iWARP. Perf, comparable. It uses existing infrastructure. You don't have to go and configure all your switches. It just works. It's just TCP in the network. So simple setup, inexpensive, well, comparable anyway. And TCP is, pretty common. Everybody understands it. Diagnosing a TCP flow is something that people are used to doing. So this is pretty straightforward. The key thing here is if you're in a data center, either one works well. But as you extend that RDMA out to your client space, if you're going out for those people who need big files moved around, they're doing video editing or big massive data sets that they're playing with, those people need to be able to do things in a simple manner without having a network engineer in every facility. And iWARP gives that capability. Bob, why don't you show us what's up?
Sure. Hello, everyone. I'm Bob Dugan from Chelsio Communications. I'm a program manager. On this slide here, what we have is our offerings of all the things that our NIC can do. That includes not just RDMA, we also do iSCSI offload. We do FC over E offload, if any of you use that. And with RDMA, of course, we do SMB direct. With iWARP, that enables things such as storage replica, so you can do multi-hop cross campuses through various switches and routers. We also have a new product out that's the next generation called T6. That's the next generation chip, our 6th generation. And on T6, we have added a speed bump. T5 currently does 10 and 40 gigabits, and T6 now does 25, 50, and 100 gig, and that's generally available next month. It's generation Gen 3 by 16 for the 100 gig adapter. And finally, one of the things that we have done is we've done a crypto engine in T6. So Currently, we're working on the software for Windows and other operating systems, but it does TLS offload SSL and IPsec. And you can do it as a look-aside, so you can use it as a crypto engine, not even use networking, or you can use it inline, even up to 100 gigabits. So with that, I think I could do my demo. I'm on number 6 here, so. All right. So, oh, there was another slide that showed the configuration.
Yes,
well, it's not important.
I was trying to get to that, and for some reason the clicker wasn't. There we go.
There we go, okay. So the demo is this. So I have 2 clients here and a server. The server has 5 NVMe devices in it. It's kind of a high-end system. The demo is only with one of these 2, the 40 gig one. I'm just showing the 10 gig just to show that multiple clients can connect to the server side. Okay, now to the demo.
Okay, now to the demo.
Okay, so what I'm going to do here is I'm just going to run this script that's running disk SPD, disk speed. And let's see, this should show the 10 gig line. And as you can see up above, it's running right here, somewhere around close to line rates.
Yep.
39.2
gig in a Win 10 client?
Yeah. So this is running Windows 10 Enterprise. It also can run on Windows 10 Pro. So this is the kinds of things you can do from video editing, CAD/CAM, oil, gas, or if you're an extreme gamer, perhaps, I don't know. Anyway, that's the demo. Thank you very much.
Thank you, Bob.